Hello! Today we're going to learn about intercepts and related functions. Now for the notes on this section, you're going to want graph paper, you're going to want a ruler, and you're going to want your graphing calculator. So if you don't have those out yet, go ahead and pause the video, get out your supplies, and then restart it so that you're ready to go. All right, Roman numeral 1, let's talk about a review of intercepts. When you're talking about intercepts, you're talking about a two-dimensional situation or graph. In other words, you're going to have x's and y's that come in ordered pairs. So just to review with you linear and quadratic, a linear function is one that comes in the form y equals mx plus b. The x is singular. So for example, y equals x plus 2 is a linear function. All right, we're going to draw a graph of that. So go ahead and draw a pair of medium-sized axes. We're going to plot this line on those axes. Okay, 2 is b, so 2 is your y-intercept. That's pretty simple. And if the x is negative 2, you have your x-intercept. So looking at this graph, if you were asked to write the intercepts, you would say that the x-intercept is this point right here, which is negative 2, 0, and your y-intercept, this point right here, is 0, 2. Most linear functions have two intercepts. If it has both an x and a y, it will definitely have both types of intercepts. If it only has an x or only a y, for example, if you had the function 1, 2, 3, this is the function x equals 3. There is no y in the equation. It's still two-dimensional, but it has no y in it. And so all you will have is a single x-intercept at 3, 0. So one-dimensional equations can still be graphed in 2 dimensions, and you can write the intercepts. Okay, so the second type of graph I'm going to review is a quadratic, which is a graph in the function form y equals ax squared plus bx plus c. So an example of this would be y equals x squared minus 1. You can tell the x is squared. It's going to be a quadratic. So draw yourself a pair of axes. And if you wanted to put this in vertex form to help you graph it, it would be y equals x minus 0, quantity squared, minus 1, which means that you have a vertex at 0, negative 1. And from there you'd plot points. If x is 1, 1 minus 1 is 0. If x is negative 1, that would be still 1 minus 1 is 0. If x is 2, 2 squared is 4, minus 1 is 3. 1, 2, 3, and negative 2 would give you the same thing. We'll be reviewing quadratics more as we go along, so don't worry if that's a little bit rusty. So this is 1, this is negative 1. So on this graph, if you were asked to give an x-intercept, there would actually be 2 of them, one here and one here. So it would be negative 1, 0, and 1, 0. If you were asked to give a y-intercept, this would be where it crosses the y-axis. In this case, it's the vertex, 0, negative 1. Now, like the linear, there are different combinations of x-intercept and y-intercept. These are harder to spot unless you sketch the graph. But if you have a parabola that opens upward like this and it doesn't touch, that won't have any intercepts at all. If its vertex is sitting on the x-axis and it opens up or down, you're going to then have an x-intercept here, and this actually eventually, way down here, will give you a y-intercept. So this one will have a y-intercept, because it'll keep going, but no x. This one has an x-intercept here, and then eventually this is going to cross over. Long ways down there, but it will eventually get a y-intercept. So sometimes they only have one, sometimes they have both. All right, we're going to do, for Roman numeral 2, we're going to use a grapher. And we're going to use a grapher to find intercepts. This is not something you'll be doing on your worksheet, but you will be doing it later, so this is a skill that you need to have. Okay, the example we're going to do is y equals negative x squared plus 4. When you do grapher problems, you do use your grapher, but you do what we call a grapher sketch, which is an approximation of what you're looking at. If they're exact numbers, you'll plot those. If they're decimals, you'll put them about where they belong. All right, so let's go to our grapher. Okay, so we want to input this equation into our grapher, so we're going to go into the y equals, or the algebraic menu, so push y equals. If you have anything in there, like I do, you can push clear, down arrow, clear, and get rid of it, and then up arrow to where you want to be. Okay, so we want to input y equals negative x squared plus 4. Remember that your negative button and your subtraction button are different. If it's a negative in front of the first term, you're going to use the negative button. So this is a negative, and then we're going to press x, which is the variable button. And then you have an x squared button here. So negative x squared plus 4. Now remember, if that was a minus 4, because it comes after the first term, you would use the subtraction. So negative comes before the first term, subtraction comes between any other terms. So there we go. Let's check our window. So here's window. And I must have z-squared the window because it's really strange. Let's go ahead and put this by 5. So for the x minimum, again, use that negative button. We're going to go negative 5, and then down arrow, x maximum. We're going to go 5. X scale, we want 1s for the tick marks. Now the y is already set to that, negative 5, 5, and 1. So we're good. We have our equation entered, so we're going to trace it. In other words, we're going to make a new graph. So hit trace. Okay. Sometimes you luck out and it lands right on the y-intercept, which it did here, 0, 4. So let me graph that. 0, 1, 2, 3, 4. Now, toggle left a little ways. If you want to know the y-intercept, the only way to find the y-intercept is direct input. So what you'll do is in the trace screen, you'll just input a 0, see how it appears on the bottom, and then enter, and it will automatically calculate for you what the y value is that goes with that particular 0. So 0, 4 is obviously the y-intercept. Now, that doesn't work for x-intercepts. You have to actually calculate them. So your calculate button is on your trace. Mine's blue, so I'm going to use the second. Second, calculate. An x-intercept is a 0, so toggle to a 0. Press enter. It's going to ask you what's the left bound. So let's find this right 0 first. So toggle to the right till it's just to the left of where you see it crossing. Press enter. Now it changes the question to right bound. Toggle to the right until it's to the right of where you see it cross. Press enter, and best guess where you think it is. Press enter, and it will come up with it. And it is indeed 2, 0. So this point here is 2, 0. This point here is 0, 4. Okay, now we're going to do the other one. So see, I'm just going over. Now see how my cursor has floated off my graph? hit trace and it'll stick it back to your graph. You want it stuck to the graph. If it's not stuck to the graph, it's not actually giving you values for your equation. All right, let's do another 0. So we want to calculate. Remember, it's on the trace button. So second, we're going to calculate, toggle to 0, enter. Left bound. Use your left arrow until you're to the left of where it crosses. Press enter. Right bound. Toggle to the right of where it crosses. Enter. Best guess. Toggle right over the top of it. Press enter. And what do you know? -2, 0. So my parabola looks like this. On a graph or sketch versus a graph, you only need the critical points. So this is what we would call a graph or sketch. In a graph or sketch, you do critical points, not all points. And you always give your window. The X window was -5 to 5 by the Y window was -5 to 5. And that's all the information you need for graph or sketch. You don't really need any other information. So the intercepts of this function, the x-intercepts were here and here, -2, 0, and 2, 0. The y-intercept was at 0, 4. So what you're going to be doing on your homework is you're going to be finding intercepts using what's called a related function. Okay, so a related function means that you replace 0 with y. So you solve in one dimension, but you answer in 2. Or vice versa. Solve in 2, go to 1. Solve in 1, go to 2. So the related function to this would be 0 equals -x squared plus 4. So if I solve the related function, I'm only going to get x-intercepts. That's all I can get. X-intercepts only. You can't get y out of a related function. So we would solve this normally. It would factor into a negative out front, x plus 2, x minus 2. We would get x equals -2 and x equals +2. These are the one-dimensional answers. If it says to write the answers as x-intercepts, then we're going to write our answers as -2, 0 and +2, 0. We're basically going to put it back on the graph as if this were a y and show what those x-intercepts would look like. So related function, that's what you're going to be doing on your homework. You're going to be solving something equal to 0. You will get x values, and you will show them as x-intercepts. That is showing your answers as x-intercepts. And the concept of related function is something